Welcome to Auditory Precision, and what we're going to go over today is really what is involved with verification and validation. And it's a big topic which is on the state test. What we're utilizing is the new IHS book. This is their new distance learning book that came out in December of 2016. And they're a big component of understanding the difference between verification and validation, which is very similar to subjective and objective. Verification or an objective test is something that cannot be obscured by patient behavior or opinion. Subjective or validation does take into consideration the patient's opinion and behavior. So the first thing that we're going to do is split this up into 4 stages, which I've found helpful to help with the test. Now, this is all going to be going over Chapter 13. And what I consider to be stage 1 is the 2cc coupler box, or the electroacoustic analysis box. And what happens in stage 1 is when we order a hearing aid, we have to make sure that what we've gotten from the manufacturer is working properly. Years ago, it was important to check at the matrix, which is a number slash a number slash another number, which was our MPO, our full-on gain, and our slope. And we can figure if all that out is accurate by utilizing this. This is the 2cc coupler analyzer box. And what we're doing is we're taking our hearing aid, we're connecting it to the correct 2cc coupler, and we're going to be running tests that will be coming out on this paper here, which in this case is like the old calculator roll of paper. There are more digital boxes now. And what we basically do here is we're going to be taking a hearing aid, attaching it to the 2cc coupler to run the test in decibels SPL, and we're going to know a lot about our MPO and full-on gain. Now, what is important to know is the type of 2cc coupler. Now, years ago, we really only had an ITE and a BTE. And so the BTE was always an HA2. ITE is HA1. So to say that again, BTE is HA2, ITE is HA1. Now, RICs are called a RIC 2cc coupler. CICs is a CIC 2cc coupler. They don't really get the numeric numbers anymore. But we have to utilize the correct one to get our correct readings. I'm going to try to keep this as simple as possible because you'll see what we're doing by splitting this up into 4 stages. But again, in stage 1, we're talking about basically when we order a hearing aid, making sure that it is working properly. And there's a couple things that we're going to do once we connect it to our 2cc coupler. In our box, we're going to find things like our MPO, our full-on gain, reference test gain, harmonic distortion, frequency curve, and this is going to let us know that the hearing aid is working properly. Now, the one thing that you'll need to know for the test is that when I'm dealing with a graph, there's a good chance that it might look the same, or at least close to one another. Now, the first thing that I want to know is my graph going up to 20 dB, or is it going up to about 60 dB? This will tell me right here. This is an MPO graph because of it going up this high. MPO can also be OSPL 90. They can use more than one term, so don't get confused with that. Know your terms. If I have a graph that looks similar, but they didn't tell me what it was, if it's only going up to 60, then I'm more looking at a full-on gain graph. Now, our full-on gain is something that, when we're talking about gain of a hearing aid, we're basically talking about full-on gain, and I'll explain that when we get to reference test gain. But there is something that we can do with this information that's coming from our electroacoustic analysis. One, all of this is running under ANSI requirements. Okay, And this is another term that you want to know for stage 1. And the ANSI requirements, when we get my MPO, there is a way to find the average to this. Now, if you can recall, to get the average of our audiogram, I'm going to take 500, 1,000, 2,000, add them all up, and then I'm going to divide by 3. That will give me my PTA. And what I'm going to be doing is almost the same thing, except I will be taking what will be considered at 1,000, 1,600, and 2,500. So it's kind of strange. We're using some interoctaves here. But if I take these and add them up from my graph and divide by 3, I'll get my MPO average. If this happens to be my full-on gain graph, and this only goes up to 60, I still am going to mark 1,000, 1,600, 2,500, add them up, divide it by 3, and now I find my full-on gain average. So again, we're talking about what we're getting from the electroacoustic analysis using ANSI standards. ANSI standards is American National Standard Institute. Term to know for stage 1. And we're going to get into our reference test gain. Again, it's a lot more detailed than what I'm teaching here, but it's just a simplistic overview. And what happens with our reference test gain is that I'm going to rotate my volume control. And this is going to be 17 less than my MPO average, right? So we figured out how to get my MPO average by taking 1,000, 1,600, 2,500, adding them all up and dividing by 3. Another name for your MPO is your SSPL90. So again, know that. But this is how you're going to know. Now, if we're dealing with a question that's asking about the gain of the hearing aid, or what gain is in the matrix, or how much gain to add to a hearing aid, we're always talking about full-on gain. Full-on gain is our gain. A reference test gain is something that we find by taking our volume control minus 17 from our MPO average. So here's the secret. If they're not talking about negative 17, if they're not talking about getting it from the MPO average, they're not talking about reference test gain. This number is a good way to know if the answer might be a reference test gain. If not, it's going to be full-on gain most of the time. So the other thing that we find out is our harmonic distortion. Okay? And a harmonic distortion is something that, again, is done within the box after we add our hearing aid to the correct 2cc coupler, which is a term to remember in stage 1. And we're going to put 70 decibels in to see how much of a percentage of harmonic distortion I have. And this is what we need to know. If it's less than 5%, we're good. If it's worse than 10%, it's bad. Okay? That is what we really need to know for harmonic distortion. Frequency response curve is the last thing that we'll talk about as far as what we get in our 2cc coupler box. And this is an ANSI standard that is probably the most complex. But again, what we have here is our frequency response curve. And what's going to happen is I'm going to plot at 1,000, 1,600, and 2,500, which is always our numbers. So other than our audiogram, where when we find our pure tone average, we're using 500, 1,000, and 2,000. We're utilizing these numbers when talking about the ANSI requirements. And so say if I plot those across this line, okay, so I got 1,000, 1,600, 2,500, I get 28, 31, and 33 that I'm getting from this side of my graph, which is in decibels. I end up getting 92. I divide by 3 and I get 30. So what I'm going to do is I'm going to plot this at 1600. So maybe right about here, I'm at 30. Then they want us to subtract 20 from here. And if I do that, I'm going to make a dotted line. So let's say I made my dotted line after minusing 20, so at 10, I made my dotted line. And where it intersects is our frequency response curve. So this is probably the most tricky when it comes to stage 1. The most important thing for the test is basically to know that the frequency response curve is part of stage 1, and it's done in the 2cc coupler box utilizing ANSI requirements.